So I'm going to give another quick overview of photosynthesis, and this time I'm going to break it down into two big stages. So as you are probably familiar, just looking at the word, photosynthesis essentially has two parts. It has photo and it has synthesis. The photo is referring to that it's going to use light somehow. And what's it going to do with that light energy? Well, it's going to synthesize something. And in particular, what it's going to synthesize, as we'll see, is sugar. So we are going to go from energy in light. Let me just write light energy. And we're going to use that light energy to synthesize sugar. Very broadly speaking, obviously this is a very, very high level overview. But light energy isn't the only input here. We're also going to need some water. And as we go into future videos, we'll see what that water is used for. It's actually a source of electrons to do this, to make use of that light energy, frankly. And we're also going to need some carbon dioxide, really as a source of carbons, because there's a lot of carbon in those sugars. We're essentially going to fix the carbon. We're going to take it from this carbon dioxide gas, and we're going to incorporate it into organic molecules and eventually into the sugar. And sugar isn't the only output. Another byproduct of this process is molecular oxygen. Once you strip a couple of electrons from the water and the hydrogen ions are stripped away from it as well, all you're left with is oxygen. And you do that twice, then you have O2 and you have molecular oxygen. And this is a byproduct of photosynthesis, but you can imagine this is very important to life on Earth as we know it, in particular for us. We would have trouble breathing if this was not a byproduct of photosynthesis. Now what I'm going to do now is break this out into two stages. And these two stages we can call the light-dependent reactions. Light-dependent reactions. And then the second stage I will call the Calvin cycle. Calvin cycle. And as the name implies, the light-dependent reactions are dependent on light. So what's happening here is we're going to take light energy, plus we're going to take the water as a source of electrons, and we're going to use these two things. To produce, let me write this in another color, to produce ATP from ADP. So we're going to produce ATP, which is a store of energy. And we're also going to reduce NADP plus into NADPH, which has energy as a strong reducing agent. So this is what is happening, broadly speaking, in the light reactions. And then in the Calvin cycle, what we're going to do is we're going to take these products of the light-dependent reactions. So we're going to take our ATP and our NADPH, and we can use their energy in conjunction with some carbon dioxide, in order to produce sugar. And let me see, have I got everything here? Oh, of course, I'm missing one of the byproducts of the light-dependent reactions, a very important one. I'm missing the molecular oxygen. So once again, this is what makes up photosynthesis, but you can break it up into these two segments. Light-dependent reaction is using the energy from photons in light, along with electrons from the water, to store energy as ATP and NADPH, and it has oxygen, molecular oxygen, as a byproduct. In order to get one molecular oxygen, you're going to have to need two of these water molecules. And then, as we go into the Calvin cycle, we can take the ATP and the NADPH, along with some carbon dioxide, and we can use that to actually store our energy as actual sugar. And as we'll do in future videos, we'll go into more depth into what exactly happens in these light-dependent reactions and what exactly happens in the Calvin cycle.